Why doesn't water burn? Do you know this? Let's learn more about this curious question. Everyone knows that water is a readily available liquid that doesn't burn and is the go-to option for putting out a fire. But why is that the case? Water is composed of hydrogen and oxygen atoms, two elements that both support combustion. Logic dictates that water should burn too, right? Yet, as we all know, that doesn't happen. Burning is a chemical process wherein two molecules and atoms combine and release energy in the form of heat and light. For anything to burn, you need two things: a fuel source to burn and an oxidizer, which is usually the oxygen on our planet. You also need heat to kickstart the process of combustion. Consider the example of burning a piece of paper. In that scenario, paper is the fuel, the oxidizer is gaseous oxygen, and heat is provided by lighting a match and igniting it. Water is made of two atoms of hydrogen and one atom of oxygen, and it's interesting to note that the two constituents of water are actually flammable. A hydrogen atom has only one electron and is therefore quick to combine with other elements to form new compounds. Hydrogen usually appears in its gaseous form in nature, which consists of two hydrogen atoms covalently bonded to each other. However, the gas is very reactive and will oxidize rapidly in the presence of an oxidizer, which makes it highly flammable. The resulting combustion produces a lot of energy, which is why liquid hydrogen is used as a fuel for spacecraft being sent out of Earth's atmosphere. As mentioned earlier, any kind of combustion requires an oxidizer. There are numerous oxidizing agents in chemistry, including oxygen, ozone, hydrogen peroxide, fluorine, and others. Since gaseous oxygen is so abundant in Earth's atmosphere, it is the primary oxidizing agent for most fires. This is why a constant supply of oxygen is essential for a fire to sustain itself. As most of us know, water is a fantastic fire extinguisher for a number of reasons, but first and foremost because it doesn't catch fire itself, despite being composed of two elements that are more than ready to participate in a raging inferno. The stability of water is because it is already burnt. As we have already discussed, hydrogen gas is highly flammable. All it needs is an oxidant to start burning. Since oxygen is the most abundant oxidant on Earth, it rapidly combines with hydrogen atoms to catch fire, if you will. The product of that fire is water. Such a combination of hydrogen and oxygen releases a great deal of energy in the form of heat and light, meaning that it's quite dangerous. The Hindenburg disaster of 1937 in New Jersey, which claimed dozens of lives, was a tragic result of this explosive reaction. This is also the main reason we don't artificially create water in labs: the unpredictable volatility. In summation, you get ashes when you burn paper, but when you're burning hydrogen atoms, you get water instead. Just as you can't burn the ashes at the bottom of a campfire, you can't burn water either.